Hi dear students, in this lecture we are going to see a basic mathematics concept which has a very strong impact on learning physics and some parts of chemistry also. We are going to learn a basic concept called as slope. You would have come across this word slope. So here you see two pictures. So this is a mountain and this is a kind of a hill. In these two pictures, which is more steeper? Which is more steeper? So obviously the first one, this one is more steeper than this one. That is, climbing this mountain is very hard than climbing this mountain. So this is more steeper. So it is very obvious. It's anyone will say that this part of the mountain is very, very hard to climb because the slope of this mountain is very, very high. So this mountain is more steeper. So that is what you understand by slope. So slope, we are going to, now I am going to give you with two diagrams and let's discuss. First part of the lecture, we will discuss what is the physical meaning of slope. So the physical meaning of slope is, so suppose 1 minute. Suppose you have two lines. We will be seeing it more mathematically, what is meant by slope, and understand it physically where it applies. So suppose there is a graph which consists of an x-axis and a y-axis. This is x-axis and this is a y-axis. If I draw two lines, I draw I draw A and B. It's kind of a part of a mountain. This is a very steeper line, obviously. If I ask you which line is steeper, either A or B, obviously your answer should be A. A is more steeper than B. That is, if someone wants to climb this incline, he finds it hard to climb incline than this incline. So your answer is, this line is more steeper. So now we have learned which is more steeper. Now let us try to understand what does the physical significance of slope with a very, very simple example. Suppose I have the y-axis and I have the x-axis here. Let the y-axis represent the price of rice. The price of rice. The price of rice. And the x-axis represents the time, maybe the days. Day 1, day 2, maybe Monday, Tuesday, day 3, day 4, day 5. Basically it is time, day 6. And now I draw a line. I draw the same two lines. So maybe I'll draw from here. So I'll put some price here. Let this be 10 rupees. And this be 15. This is 20. This is 25. This is 30. I put some price. So I draw two lines here now. I draw two lines here. One line I draw like this. The other line I draw like this. I draw like this. Suppose this line, I say that this line represents the price of rice in Tamil Nadu. In Tamil Nadu. And this line represents the price of rice in, say, Punjab. So I ask you a very simple question. What do you understand by these two lines? It is very, very obvious that we understand 2 points here. On day 1, the price of rice in both Tamil Nadu and Punjab is rupees 10. But as it goes on, in Tamil Nadu, the rate at which the price increases in Tamil Nadu is more than the rate at which the price increases in Punjab. Now, if I ask you which line is steeper means, obviously your answer will be Tamil Nadu line is steeper. This line is steeper than this line. So what you say basically from this graph is, the rate at which the price of rice increases in Tamil Nadu is more than the rate at which the price of rice increases in Punjab. That is per day, maybe if this is the second day, this is approximately 12 rupees. If I say this is 12 rupees. In next day, this is approximately maybe 12.5 rupees. So in one day in Punjab, if I'm going to draw a graph, draw a line here, this is approximately 12 rupees. I say this is 10 and this is 15. So this should be approximately 12. On the third day, if we're going to draw a line, it is approximately 12.5. So the price of rice in one day in Punjab increases by rupees 0.5 rupees, just by 50 paise. Now, if we take the same instant in Tamil Nadu, let us see what happens. In Tamil Nadu, if in one day, let us see how much price increases. So in Tamil Nadu, on second day, the price is somewhere around maybe 30 rupees. 30 rupees, approximately 30 rupees. On the third day, the price is approximately 17 rupees. So from 13 to 17, that is 4 rupees it increases. So in Tamil Nadu, in one day, the price increases by rupees 4. Whereas in Punjab, it increases by 0.5 rupees per day. 0.5 rupees per day. Per day. And here it increases by 4 rupees per day. Per day. So what we understand is the slope of the line is nothing but the rate at which some quantity changes with respect to some other quantity. In this case, in this example, this quantity, this is price, this quantity is price and this quantity is time. In this example, the rate at which the price increases with respect to time. That is this example. But it can be anything. This could be this x-axis could be a temperature and this could be distance. The temperature increases with respect to distance. Suppose I have a fire pot here. Suppose I have a fire pot here. This is fire, very hot object. So a person standing here will experience more heat than the person standing here. So the temperature here will be more than the temperature here. So the temperature changes with distance. If I try to plot it in a graph, I may get with respect to distance, I may get a graph like this. The temperature decreases with respect to distance. This is temperature, this one is distance. So this is temperature and this is distance. This shows you the rate at which the temperature decreases with respect to distance. The rate at which the temperature falls down with respect to distance. So the slope of any line, this line, if you see difference between this line and this line, it's like climbing down the mountain. The slope is negative here. The slope is negative here in this case. But in this case, it is climbing up the mountain. So always you imagine that you are traveling from right to left. Then you are climbing up the mountain here. And in this case, from right to left, that is along the distance. Along the distance is from right to left. Along the time is from left to right. Sorry, from left to right. Along the distance is also from left to right. So when you are traveling always along the distance, because your x-axis is going from left to right. So here you are climbing. You call this as a positive slope and this as a negative slope because the temperature decreases here. When the rate at which one quantity decreases with respect to other quantity, you define it as a negative slope. And in this case, the price of rice increases with respect to time. So you call it as a positive slope. So basically what we understand by slope is, it could be price of rice, in this case, price of rice and time. In this case, temperature and time. In some other case, it could be position and time also. Where you are located. You are located, a person is located at morning 9 o'clock at his house. And then at 10 o'clock, he is traveling, he is standing in maybe a bus stop. And then 11 o'clock, he reaches his office. And then with respect to time, his position changes. So if you draw a graph between position and time, suppose you have a position, suppose there are two runners. So let the position, let this be the x-axis. This be a running track. Two boys are standing here. And one boy runs, both are having a and B. or having a race. So if I plot their positions, x positions, so initially 0, both are at 0. I'll call this as 1 meter, 2 meter, 3 meter, 4 meter like this. So if I draw two lines here like this is for B, this is for A. This is position versus time. This is position versus time. Time. This is position. This x-axis represents time. So at 1 second, in 1 second, he comes to x is equal to 1, whereas he doesn't reach 1. In 2 seconds, x reaches 1.5. So A, B, this one is A. A reaches 1.5 meters and B reaches not even 1. So which means that what you understand is A is running faster than B. The A is running faster than B. So this graph represents the rate of change of the position of the runners with respect to time. So he covers more distance in the same time in which B covers. In the same time, the B covers lesser distance. That means that A is running faster than B. So this is rate of change of position. This is rate of change of price. This is rate at which the temperature changes with respect to distance. So generally, if anything changes with respect to time, you don't especially say that with respect to time. The rate of change of price of rice means by default it is with respect to time. But if it is with respect to some other variable, in this case it is with respect to distance, you call it as distance, the rate of change of temperature with respect to distance. Sometime in physics, they call this rate of change of one quantity with respect to other quantity as gradient. Maybe in future classes you will be learning this one. They call this one as gradient. Gradient is a kind of slope only. Gradient is nothing but gradient means what? Slope only. That is slope, the other word for slope. But whenever quantity changes with respect to distance, they call it as gradient. Whenever a quantity changes with respect to time, they call it as rate at which the quantity changes. So what is from our discussion, what we understand is the slope is nothing but the slope is nothing but the rate of change of one quantity with respect to other quantity. We have seen 3 examples. In this example, we have seen price of rice with respect to time. In this example, we have seen the temperature with respect to distance. Here we have seen the position with respect to time. So generally, the what is our conclusion here from all these examples is we understand that the slope represent the rate of change of one quantity with respect to the other quantity. So this is the basic meaning of slope. So this is what you have to understand. So understanding what is the physical meaning of this, what is the physical significance of slope. So we are about to see the physical significance here. So what is the physical significance of slope? The slope represents the rate of change of one quantity with respect to the other quantity. So this is the physical meaning of slope. Now, having seen, we have come across 2 things here. We learned to identify which is most cheaper. The second one we learned is what is the physical meaning of slope. The physical meaning of slope is the rate at which one quantity changes with respect to other quantity. So that is the physical meaning of slope. So the rate at which one quantity changes with respect to the other quantity. Now, having understood it qualitatively, now we are going to quantify what is quantitatively. We are going to understand what is slope. So quantitatively understanding means we are going to just now we have compared 2 slopes. Instead of that, now we are going to find out the slope of a given line or anything, given mountain or given line or any graph. If you have a line, how to find the slope of the line. So slope generally, now we will try to understand it more from the basics. So slope is Suppose if I draw two lines here, I think this is a wall, and this is a floor. This is a wall and this is a floor, and I place two ladders. I place two ladders. This is ladder 1. This one is ladder 2. One is one I drawn in. This is ladder 2. This is ladder 1. The black ladder and the red ladder. The black ladder, which ladder has more slope? Yes. Obviously, your answer should be the red ladder. The red ladder has more slope here. So you can see that the red ladder has more slope here, because it is if a person is going to climb this ladder and this ladder, say a person finds difficult to climb the red ladder than the black ladder. So this ladder is more slope. So here, if you take this triangle, this right angle triangle, for both red as the hypotenuse and black as the hypotenuse, you can observe that for both the triangles, the opposite side is same. Only the adjacent side decreases here. Here, adjacent side for red ladder is less than the adjacent side of. If the adjacent side decreases, then the slope of the line is being the opposite side being the constant. If the adjacent side alone decreases, then the slope of the line is more. That means we understand that the slope is directly proportional to the slope. Slope is directly proportional to, inversely proportional to adjacent side. Inversely proportional to lesser the adjacent side. For this, the lead ladder, the adjacent side is less. So slope is inversely proportional to adjacent side. Now let us take the other example. The same ladder example. Now I place two ladders. So in this case, both these ladders have same adjacent side, but opposite side of red ladder is more than the opposite side of black ladder. So which ladder in this case has more slope? Obviously the red ladder, because a person has climbing here means he finds this to climb harder than this one. So the red ladder has more slope here. So that means that more the opposite side being the adjacent side same for both the ladders. If the opposite side is more, then the slope is also more. So I can say that slope is directly proportional to, okay, I'll write again. Slope is directly proportional to opposite side. Opposite side. So from these two, we understand that we can write that slope is equal to, if there is no other factor involved, I did not write this proportionality sign. I can directly write slope is equal to opposite side by adjacent side. So in mathematics, in your higher class, in your high school, you would have studied opposite side by adjacent side is nothing but the tan theta. Where theta is the angle with the horizontal. There's nothing but the tan theta. Where theta is this side, this side. This angle is theta for this side. So is directly proportional to tan theta. Now we have written a formula to measure slope actually. So we have come that slope is equal to tan of tan theta, where theta is the angle with the horizontal. Theta is the angle with the horizontal, or say something. Mostly we say that with the x-axis. Theta is the angle with horizontal. With horizontal. So this is now we have started measuring slope. So first we learned which is steeper, which is less steeper. Then we learned the physical meaning of slope, which you should never forget. What is the physical meaning of slope? It is the rate at which one quantity changes with respect to the other quantity. Now we have importantly found out what is the slope of a line. So if the line makes angle theta with the x-axis or the horizontal, then the slope is nothing but the tan theta. So now let us see this line today. Let us take another example here. Let us take another example here. 1 minute. So this one, if I have a line here like this, and this angle is theta. If I consider 2 points on the line, this point is x1 comma y1, and this point is x2 comma y2. x2 comma y2. Now here, which means that this is x1 and this is y1, and this one is x2. That this whole length is x2 and this is y2. Now if I draw a line here, I get you can see I get a right angle triangle. Maybe I will shade this right angle triangle. I get a right angle triangle here. Now what is the slope? If this is theta, then this angle should be theta. This angle should also be theta. So what will be the slope of this line? What will be the slope of the line? We know already slope is equal to tan theta. Slope is equal to tan theta, which is equal to opposite side by adjacent side. By adjacent side. Now in this triangle, what is the opposite side? This is the opposite side. So the whole thing is y2, and this one is y1. So the opposite side is this is y2. This is. So this is the opposite side. This opposite side is y2 minus y1. So this is y2 minus y1 divided by x2 minus x1 divided by x2 minus x1. So this is the slope. So this is the slope of the line now. So we got one is tan theta. There now we know if you know the 2 points on a line, the slope of the line is y2 minus y1 by x2 minus x1. So we will see some examples. If there is some very easy examples based on what we have done. There are 2 ways we can find the slope. One is if someone gives you the angle here, someone gives you this angle is 30 degree, the slope of the line will be tan 30, which is 1 by root 3. Someone instead of that sense is someone if the given quantity is not if they are given it if there is a line here like this, they are given you this is x1 comma y1 or this is 3 comma 2. This one is 3 comma 2 and this line is 7 comma 6. So this is x1, this is 3, x1 is 3, x2 is 2, y1 is 7, y2 is 6. So the slope here is 7 minus y2 minus y1, 6 minus 2 divided by 7 minus 2. 6 minus 2 is 4 divided by 4. 7 minus 3 is also 4. So slope is equal to 1. Or if they ask you what is the angle with the x-axis, you can equate slope is nothing but tan theta. Tan theta is equal to 1. So theta is equal to 45. So mathematically you can find all these things. So there are 2 examples. One given is angle, the other one given is 2-point form. This one you call it as a 2-point form. You can find the slope of any line by this method. You can find the slope of any line by this method. Now, so far we were doing slopes with, we learned what is the slope of the line, what is the physical meaning of slope of the line, how to find slope when a given angle is given, and an angle is given, how to find slope when 2 points are given. Now we are going to see a different, not a line but a curve. We are going to see a curve. How to find the slope, how we are going to do when the price of rice itself is not a straight line. When you plot it in a graph, it need not necessarily be a straight line. It can be any line. It can be any line for that purpose. It can be any curvy line. It can be a curve also. It can be a curve also here. So suppose the price of rice is like this. The same example I'll take. If this is the price of rice, the price of rice there, and this is the time, day 1, day 2, day 3. Suppose instead of a line, you get a curve like this. So line, if you get a curve like this, this is day 1, this is day 2, this is day 3, this is day 4, this is day 5, this is day 6, this is day 7. So now if you see at every point, here the rate at which the price rises is not constant. You can very well see that day 1 the price was somewhere around here, and slowly it increases. Day 3 it starts increasing more and more steadily. It starts increasing more and more steadily, and now it increases somewhat. The rate at which the price increases is more than in this side. We can put some points here. This is A, maybe this is B, if this is C, and this is G, and this is E. These points are there. So we can see that from A to D, the rate at which the price increases is somewhat better. It doesn't increase much, but it increases. From D to C, the rate at which the price increases is slightly greater than the rate at which the price increases from A to D. From C to D, it is even more steeper. This line is even more steeper. So if someone is going to climb this mountain, then this part of the mountain is somewhat easier for him to climb. That means that the slope of this part of the curve is less than the slope of the curve. Slightly, it becomes harder for him to climb here. So from D to C, it is harder. From C to D, it becomes even more harder. From D to E, it becomes almost very, very hard for him to climb. This part of the curve is very, very steeper. Which from this, what we understand is every part of the curve here doesn't have the same slope. Every part of the curve has different slopes here. So in this case, what is different from this case and the previous case is, in the previous case it was a straight line. It was a straight line. So a person is going to climb now throughout the mountain, the same slope he has. He has the same slope. So the slope doesn't change here. The slope doesn't change. The rate at which the price increases doesn't change here. But in this case, maybe from 60th day to 7th day, 6th day to 7th day, the price increases unexpectedly very high. The price of rice increases unexpectedly. 6th day it was this much. This was this much. 7th day it jumps to very high value. So that means here it is more steeper. Here it is more steeper. So the rate at which the price increases is more here. That means what you understand, if this instead of a line, if this is a curve, then the slope itself is a variable slope. It's not a constant slope everywhere. Everywhere you get one slope. So how to find what are the quantities we will be interested to find in this one is, suppose I'll draw this example once again. I'll draw this same graph once again. If this is the price of rice and this is the time. This is the price of rice and this is the time. I draw a graph like this. I take some day, say some time t. I take this as some t. At some time t, the price of rice is some function of time. The price of rice depends upon time here. So this is some function of time. And P of t is nothing but some value of price at that time. price value at that time. 1 minute. The price of rice at this time is P of T, which means that the price of rice is this represent the price on this time. That is represent mathematically like this. You need not get much focus on this one. P of T is nothing but the price at this time. The price at this time. This may be any number. It depends on time. This is nothing but a function. P is a function of time. Similarly, after some time, after some days, maybe after some days, I call it as a del T. After some time, in physics, del means change. Del means change, an increment. Del means an increment, a change in time. After some time, maybe this is the first day and this is the fourth day. So the change in time is 3. I'm trying to generalize it. So this is T plus del T. After 3 days means T plus del T. At this time, let the price of rice be something else. On Tth day, the price of rice is P of T. On T plus del T day, the price of rice is here P of T plus del T. P of T plus del T. The P of T. This P of T plus del T is nothing but here you are writing this price. This price is always a function of time. It's a function of time. It depends on first day, what is the price, on 5th day, what is the price, like that. So if del T is the increment in a day, you are looking to this is the first day, suppose an example, and this is the 5th day. So del T is 4 days. So after 4 days, the price is P of T plus del T. This may be some value. This may be, maybe this is 20 rupees and this may be 50 rupees. This may be 50 rupees. So maybe this may be a Tuesday, and this may be Friday. This may be a Friday. This may be a Friday, and this may be a Tuesday, Wednesday, Thursday, Friday. So there are 2 days between them. So del T is 2 days. So now if I draw this point between this point and this point, if I draw a line, here between this point, if this is a straight line, AB is a straight line, then the slope of AB, what does that represent? The slope of AB? This is the angle with the horizontal. This is the angle with the horizontal. What will be the slope of AB? Slope of AB should be equal to opposite side. This is the opposite side. Here you see that the P of del T is the entire thing is P of del T. The entire thing is P of del T. P of T plus del T. And this one is this value. That is P of T. This value is P of T. So the opposite side is, this is the opposite side. So slope is equal to, I will call it as BC. BC by adjacent side is AC. Adjacent side is AC. So what will be the slope of that line? This line in mathematics, you call this line as a secant. This line is a secant, or sometimes they call it as a chord. So BC. BC is nothing but, BC is the whole thing is P of T plus del T, and this one is P of T. So BC you can write it as, that is 50 minus 20. This 20 rupees, then this is 50 rupees means. So this is 50 minus 20 is 30 rupees. So instead of giving some numbers, I am trying to write it as a function. So some function of time, some price on Tuesday. This is price on Tuesday. This is price on Friday. This is price on Friday. So what is the increase in price from Tuesday to Friday? It is, in this case, it is 30 rupees, or you can write generally as P of T plus del T minus P of T by, and this is del T. This is del T, so adjacent side should be del T. This also should be del T. So this is del T. So what does this slope represent? The slope of the secant. I'll write the slope of the secant here. Slope of secant. The slope of the secant. What does the slope of the secant represent? The slope of the secant represent the rate at which the price of rice increases from Tuesday to Friday. It is the average rate. It is the average rate at which the price increases. It is not. It doesn't tell you how much it increases on Tuesday, or how much it increases on Wednesday, or how much it increases on Thursday, or how much it increases on Friday. Instead, it's telling you how much it has increased from Tuesday to Thursday. That is, in 3 days, how much Tuesday, Wednesday, Thursday. Maybe 3 or 4 days, how much it has increased. So in the span of 3 days, the price has increased by 30 rupees. So it has increased 30 rupees for 2 days. So this is Tuesday, in between Wednesday and Thursday. So 2 days. So the price has increased by rupees 30 in 2 days. So you try to understand that it is 15 rupees on an average per day. On an average per day. It actually doesn't happen like that. Every point the slope is very, very different. On here it would not have increased much here, but here it would have been increased. On Friday it is increasing very high. So this is nothing. This is not something which is very instantaneous. On this day, what is the increase in Soti? We are not finding what is the increase on that day. Instead, we are finding what is the increase on a span of 2 days. On a span of 2 days. So we call this as average rate. You call this one as average rate. Average rate. Instead of writing this one like this is a change in price. The numerator is a change in price. So you can write del P by, this is the change in time, del T. Del P by del T tells you nothing but the average price, average rate. Average increase of price of rice in a particular time. I'll tell you one more example. Suppose I start from here, I start from Chennai and go to Bangalore. Suppose I reach Bangalore after 6 hours, and Bangalore is 300 kilometers from Chennai. If it is 300 kilometers from Chennai approximately, I reach in 6 hours. Then I say that 300 kilometers in 6 hours means in 1 hour I am traveling 50 kilometers. So I say that my average speed is 50 kilometers per hour. That doesn't mean that I would have traveled throughout the journey with 50 kilometers per hour, but that is an average speed. I might have traveled 150 kilometers and there is no traffic, or I might not have traveled when I am standing in a toll gate, or if the very, very high traffic somewhere near Punamalli means I would have been absolutely almost I would have been stranded and I would not be moving. But in 6 hours I reached back. So that means that on an average I travel at 50 kilometers per hour. On an average I am traveling at a speed of 50 kilometers per hour. So it doesn't tell me what is the speed at every instant I'm in my travel. It doesn't tell me what is my speed at this 50 kilometers per hour may not be the reality. It is an average. What is the speed at which I'm traveling when I crossed first toll, or when I'm traveling, when I cross the Punamalli bypass or the Vellore bypass, or anything like that. At a particular position, what is the this 50 kilometers per hour does not tell me what is the speed that I traveled at every instant of time. It doesn't tell me what is the speed at, but it tells me an average rate at which I travel. On an average, I am traveling at a rate of 50 kilometers per hour. So that is what you call it as the slope of the secant. So slope of the secant always represents the average rate. The slope of the secant always represents the average rate. Now listen, this is very, very important. We are getting into a very, very important concept. Slowly we are getting into the most important concepts. So now I will summarize what is here, we have done. The slope of the secant represents average change, average rate of change. The slope of the secant represents the average rate of change. This is what we understand. The slope of the secant represents the average rate of change. So the slope of the secant doesn't tell you anything. What is the rate at which it changes instantaneously? Now, next topic is we were going to try to find how to find the slope of the, or else how to find the rate at which something changes instantaneously. So, for how we are going to do this one is, this is very important for you to listen very carefully. Almost we are reaching the climax. So let us take the same example I'm taking. If I'm taking the same example. So earlier, A was here and B was here. So when we try to find the rate of change from A to B, we drew a secant here and we try to draw what is the rate at which it increases. Now, if I want to find the rate at which it increases very close to A, means instead of having B here, I'll bring that point B very as close as possible. As close as possible. If this one is X T, I'll try to bring this point, instead of here, it was here somewhere. Instead, I'll try to bring this point as close as possible and try to find what is the slope of that very tiny line. If I'm going to place T very close, that point B, if I'm going to place very close here, then here the del T is become very small. The del T here is almost tending to 0. The del T is almost tending to 0. Now my B, instead of being there, if I bring it here, and if I connect this line, if you see, it almost touches only one point. It almost touches one point, or else I'll draw it properly. It almost touches only one point. Now, if you are going to extend this one, this is going to be theta. Now, if you see this point, now we know that this is del T. Again, I'm calling it this as del T only, but del T is tending to 0 here. This is del T, and what will be the slope of the slope? What is the slope of that test? Very close. If the A and B are almost very close and del T is almost really very small, very close to 0, then instead of this one, you call this as instead of a secant, you call this line as a tangent. You call this line as a tangent. So if we try to find the slope of the tangent, it is nothing but the slope. It is also almost a secant where A and B are very close to each other. So that is the only thing where you use some kind of literature, a mathematical literature. You see the slope of the tangent, the slope of the tangent is equal to something like del T tends to 0. Del T tends to 0. I use this literature. Del T tends to 0. P of T plus del T minus P of T. This is the slope of the secant. In the slope of the secant, I am just making del T is almost 0 by del T. This is the slope of the tangent. This one is the slope of the tangent. Del T tends to 0. They use a symbol called as limit del T tends to 0. You are applying some kind of limiting for the value of, you are limiting the value of del T to 0. So that is the meaning of this. And you will learn in mathematics more in detail about these limits and all. You will learn more in detail in mathematics. But this is something which is basically you should understand to do science even from the kinematics. That is almost your first chapter. So limit del T tends to 0, P of T. This P of T plus del T minus P of T is the slope of the secant. You understand very carefully. The P of t plus del t minus P of t is the slope of the secant. When you are applying this limit to that slope of the secant, it becomes the slope of the tangent. Because when B is here, the line becomes like this. But when B is here, the line becomes like a tangent. So that is why if you are going to apply this limit del t tends to 0 to this slope of the secant, that entire slope when del t tends to 0 becomes the slope of the tangent. When this del t is equal to 0 or tends to 0, the secant is becoming a tangent. Similarly, the slope of the secant is becoming a slope of the tangent when you apply this limit del t tends to 0. So instead of writing this bigger, very what you call it as a very complicated term, instead people use to write this one as dy by dx. dy by dx. Again, you should understand that dy by dx is not d into y by d into x. It is dy is a very small change in y divided by very small change in x. Del y by del t is average change in I am using the, I should not use d in this case. It is dp by dt. dp by dt. dp by dt. dp is a very small change in price on Tuesday itself. On Tuesday, 10 o'clock, 10 a.m. there would have been one price. 12 a.m. there will be some other price. What is the change in price on that very day itself? So that is telling you the rate at which the price changes on that instant, on Tuesday itself. Earlier it was telling you, the slope of the secant was telling you the rate at which the price increases in a span of 2 days. But now it is telling you on that day itself. Maybe in 2 hours. 2 hours is almost 1 by 12 of a day, 1/12 of a day. 2 days you are coming to 1/12 of a day. What is the rate of change? That one you call it as the instantaneous rate at which this instantaneous rate. This one is called as, so instead of representing as del p by del t, you change the representation to dp by dt. Don't get confused much about this. dp is like del t. Del is a change, means t is a very small change. Del means del p is a if del p is the average change in price, means dp is the very small change in price. If del t is the average change in time, means del t is, if dt is del t is average change in time, means dt is a very small change in time. So dp by dt is the, you call it as the instantaneous rate. This one you call it as instantaneous rate that changes on that day itself, on that instant itself. Instantaneous change. Instantaneous rate, not change, instantaneous rate. Instantaneous rate. It is called as instantaneous rate. So this is the meaning of dp. What we conclude that the slope of the tangent is the instantaneous change. The slope of the tangent is the instantaneous change. The slope of the secant is average change, and slope of the tangent is instantaneous change. So this is the most important thing for you to understand. Now listen, if at all there is some kind of confusion in the whatever I have explained to you, it should be that function, that one function, which I'll give you one small example. Suppose if the price of rice depends on time. So anything which changes with respect to, there is one dependent variable, the other one is an independent variable. There is one dependent variable, the other one is an independent variable. Now time is an independent variable. The price cannot determine the time. Only based on time only price changes. Based on time only price changes. So suppose the price of rice is given with respect to time as t squared, means when t is equal to 1, when time is equal to 1, the price is 1. maybe 1 rupee or something. When t is equal to 2, that is second day, the price becomes 4. When t is equal to 3, the price becomes 9. Or it can be, I'll add 2. When first day, the price is, now what is it? 1 squared is 1, 1 plus 2 is 3. On day 1, when t is equal to 1, price is equal to 3 here. When t is equal to 2, second day, the price is equal to 2 squared, 4, 4 plus 2, 6. When t is equal to 3, price is equal to 9, 10, 11. So this price is a function of, this is only you are telling the price depends on value of t. That is what you call it as a price as a function of time. This function can be anything. This function can be p is equal to t squared plus 2, or maybe p is equal to 3. If p is equal to 3 means the price is 3. It is a constant price. It doesn't change with respect to time because the time is not in this one. If p is equal to 3t means, so here you can see that on first day t is equal to 1, what is the price? Price is 3. When t is equal to 2, the price is 6. When t is equal to 3, the price is 9. So here you see in 1 day price increases 3 rupees, and here it increases 6, 11, 5 rupees. From 2 to 3 it increases 5 rupees. The rate of increase in this case is variable, but in this case, 1 day it increases 3 rupees. On the next day also it increases by 3 rupees. So the price of rises. So this will be a straight line when you draw it on a graph, whereas this will be a curvy line when you draw it on a graph. That is why it is having a variable rate of change, but whether this is having a constant rate of change. This is what you mean by function means. This is what you mean by function. Now let us try and find how you can, I'm going to teach you how you can find this dp by dt or dy by dx or anything if a function is given. If a function is given, how to find dy by dx or dp by dt, anything like this. Now let me take one example. If I am giving you some function, some random function I give you like y is equal to x squared. So y is nothing but a function of x in this case. Y is a function of x. So y depends on value of x. For different values of x, y will bear some values. One value for when x is equal to 1, y will be 1. When x is equal to 2, this x is called as the independent variable and y is called as the dependent variable. So instead you can call this an f of x and y, or else I can take an example which you understand, because p is equal to t squared at t. If p is equal to t squared, where p is a function of time. This is nothing but p is a function of time. So instead of writing p is equal to t squared, you can write p of t also. P of t is equal to t squared. Now, if some mathematically, if they ask you to find dp by dt, simply you write the equation. Whatever we have done so far, dp by dt is equal to, dp by dt is the slope of the tangent of this curve, slope of the tangent of this curve. dp by dt is maybe limit del t tends to 0, maybe small t, p of t plus del t minus p of t. This is something which I have written already, which I have explained it already, by del t. So this will become limit del t tends to 0, p of t plus del t. Here we know that p of t is what? Here, listen here. Here p of t is given to be t squared. So p of t plus del t will be, instead of t you have to substitute t plus del t. P of t plus del t will be, instead of t you substitute t plus del t. So this will become t plus del t the whole square. You can even expand this one. t squared plus 2t del t plus del t squared. Del t is a single term, del t squared. Now what will be p of t plus del t minus, this is p of t plus del t minus p of t. So this is the first equation maybe. This is the second equation. What you have in the numerator is second equation minus first equation. When you subtract this minus this, then this t squared and this t squared will get cancelled. So I will get 2t del t. Maybe I can take even del t common outside and write it as 2t plus del t. See, when I take this del t inside, it becomes 2t del t into del t squared. That is 2t del t into del t squared. Because the t squared and t squared gets cancelled because I am subtracting the second equation minus first equation divided by del t. Now this del t and del t gets cancelled. So when I supply this del t tends to 0 here, this is so small that you can neglect it and write this one. I have supplied this limit, so I need not write this limit again. This literature I need not again repeat because till this I have not supplied, so I have written this one. Now if del t is equal to 0, then this becomes 2t. So what is dp by dt here? dp by dt is 2t. Same thing you can do with respect to x and y also. Listen, I'll take this as x cube. F of x is x cube. What is f of x plus del x? Is equal to x plus del x the whole cube, sorry. X plus del x the whole cube. So this will become x cube plus 3x del x squared plus 3x squared del x plus del x cube. So this is the first equation. This is the second equation. Now you are asked to find, in this case it is y and x. So you are asked to find dy by dx. You will find dy by dx. dy by dx is limit del x tends to 0, not del t in this case, del x tends to 0. F of x plus del x, instead of p of t plus del t, I am writing f of x plus del x minus f of x divided by del x. The numerator is the second equation minus first equation. When I subtract this minus this, then the x cube and x cube will get cancelled. So I'll write down this one. I'll take del x common outside. So this will become limit del x tends to 0. F of, sorry, instead of f of x plus del x minus f of x, I can write these three terms. If I take del x common outside there, I will get 3x del x squared, 3x del x plus 3x squared. I take a del x common outside plus del x squared. I take a del x common outside, so it will be del x squared by del x. I can cancel this del x and del x. So this will be limit del x tends to 0. (3x del x plus 3x squared plus del x squared. So when del x is very, very small, I can neglect. When I substitute 0 here, it becomes 0, and this also becomes 0. So the remaining term is only 3x squared. 3x squared. That is, I can summarize what these two problems. So when y is In the first problem, it was p, but I'm writing it as y. When y is equal to x squared, dy by dx was 2x. This was the first thing which I proved. When y is equal to x cube, dy by dx is 3x squared. This is something which I proved here. Dy by dx is 3x squared. Similarly, from this, logically you understand this, 2 is coming here and this becomes, the power loses by 1. Here also this 3 is coming as a coefficient and the power loses by 1. So generally, if y is equal to x cube, it can be proved that dy by dx is, sorry, x power n. Y is equal to x power, it's general number. Y is equal to x power n. You can prove dy by dx is n x power n minus 1. Now, if you are going to remember this one, all this stuff what I did is for you to make you to understand what is dy by dx. Here, this I've never tried to teach you mathematics here. So in future, if you remember this one, any function of this type, x power a constant, you can always do it this one. One example I can do. Suppose y is equal to x power 7 they are given. You can immediately write dy by dx instead of doing all this stuff what we did. Dy by dx is equal to, this 7 will jump here, so it becomes 7. This x power, this will lose by one number, so it becomes 6. Because see here, this 3 is jumping here and this is losing one number. This 2 is jumping here, this is losing one number, that is like 1 only here. Here this n is jumping here and this power loses by 1. So 7x power. So y is equal to, suppose y is equal to x power 9 means, so immediately you should be writing dy by dx is, without the most important thing here is not how to differentiate, but understanding what is dy by dx. Again and again I'll tell you, dy by dx is nothing but the instantaneous rate at which a quantity y changes with respect to the quantity x. That is 9x power 8. That is 9x power 8. So that's all for this part of the lecture. We will continue this calculus and do more of its applications and other things in the next lecture. Thank you all. To get more notifications of these kind of lectures, you subscribe and press the bell button so that you will get the notifications. Subscribe our YouTube channel and press the bell button. Thank you all.